All right, let's dive right into this explainer and unpack the blueprint for training the next generation of aerospace CNC machinists. In aerospace, a single micro-inch out of tolerance, literally a fraction of the width of a human hair, can ground a flight or compromise a multi-million-dollar mission. The stakes are absolutely monumental, right? Which is why the way the industry trains the people making these parts is so incredibly critical. Today, we're exploring a comprehensive 24-week curriculum pathway designed by industry experts to transform entry-level individuals into shop floor-ready aerospace machinists. Let's see exactly what it takes to build a highly skilled workforce from the ground up.
Here's our roadmap for today. We're going to cover the overall blueprint, break down the 24-week timeline, dig into core technicals like blueprint reading, look at safety credentials, evaluate day one shop floor readiness, and finally, ask for your industry feedback to validate the whole framework. Starting off with Section 1, a blueprint for aerospace machining and how we go about solving the industry skills gap. 700. That's a huge number, right? Well, that represents the absolute maximum recommended instructional hours it takes to forge a highly capable, shop floor-ready machinist. Depending on the specific track, the full program is designed to run anywhere from 400 to 700 hours. It's a massive, concentrated investment of time. But hey, when you're dealing with aerospace-grade materials like titanium or Inconel, you simply cannot cut corners. Every single one of those hours is deliberately engineered to build the rigorous technical and workplace skills required for entry-level roles in this demanding field. The whole purpose of this curriculum, it completely aligns with what aerospace employers expect and demand from day one. We're going way beyond just teaching a student how to press a green button to start a machine cycle, you know? It's a ground-up emphasis on precision machining. It dives deep into blueprint interpretation, rigorous quality systems, strict process discipline, and most importantly, safe machine operation. It's really about instilling a mindset where precision and safety aren't just rules they have to follow, they become total second nature. Moving right along to Section 2, the 24-week training framework, where we lay the foundation. Let's look at the actual timeline of how a novice builds up to a competent operator. Over a 16 to 24-week journey, the pathway is carefully staggered to really lock in retention. Weeks 1 through 4, that's interactive classroom instruction, getting the theory, the shop math, and the safety protocols fully dialed in. Then, weeks 5 through 16 transition into heavy, hands-on CNC laboratory training. This is where theory meets heavy machinery, and well, the chips actually fly. Finally, weeks 17 through 24 cap it off with industry-based projects and highly recommended internships. It perfectly pressure tests that foundational classroom knowledge out in a real-world manufacturing environment. Next up is Section 3, Precision, Blueprints, and Setup. We're talking programming the machine. Now, check out this crucial technical language, GD&T, or Geometric Dimensioning and Tolerancing. Before a trainee even thinks about touching a CNC mill or lathe, they absolutely have to master this. It's a highly precise mathematical language used on engineering drawings to describe a part's exact geometry and allowable variation. I mean, a part might look totally flat to the naked eye, right? But GD&T dictates exactly how flat it needs to be down to the 10,000th of an inch. If a student can't interpret these complex principles, they just can't machine aerospace parts. It's the absolute bedrock of modern manufacturing communication. And the technical programming for the student is incredibly exhaustive. On the operations side, it covers CNC milling and turning, right down to foundational manual machining skills so they actually understand how metal cuts. For setup, it's all about tool offsets, work offsets, and really complex fixturing. After all, running a machine is one thing, but locking down an expensive aerospace forging so it doesn't move under immense cutting pressure, that's a totally different ballgame. And, of course, they have to fundamentally understand programming, writing G-code, navigating CAM software, and troubleshooting toolware. But here's the thing. Technical chops just aren't enough on their own. Industry feedback consistently shows us that technical skills get you the interview, but durable workplace skills get you the career. You have to balance both. We're talking about a relentless safety mindset, extreme attention to detail, everyday dependability, and top-notch problem solving. An instructor can teach complex G-code all day, but if a student lacks dependability or has a bad attitude, they instantly become a liability on a shop floor. I mean, a single mistake could crash a $500,000 machine tool. Which brings us to Section 4, Safety, Quality, and Credentials, Performing Quality Checks.
To really boost graduate employability, this curriculum is heavily aligned with gold standard industry credentials. It encourages students to earn NIMS credentials from the National Institute for Metalworking Skills, which act as a nationwide benchmark for competency. We also integrate the OSHA 10-hour general industry certification to lock in that critical safety mindset right from day one. Plus, stacking manufacturer-specific certs like Haas on the machine side or Mastercam and Autodesk Fusion 360 for software gives employers immediate, verifiable proof of what a candidate can do before they even step onto the floor. Beyond those certs, a deep awareness of AS 9100 aerospace quality requirements is completely non-negotiable. The curriculum immerses students in lean manufacturing, statistical process control, and strict documentation protocols. In aerospace, traceability is literally everything. Trainees learn that they aren't just making a metal bracket, they are maintaining a critical chain of quality that stretches all the way up to an aircraft cruising at 30,000 feet. If the FAA audits a shop, they need to know exactly who machined a part and who inspected it. If an operation isn't documented properly, legally, it might as well have never happened. And we've got to make sure the training environments actually mirror modern shop setups. You simply can't train the future aerospace workforce on obsolete 30-year-old equipment. Programs using this blueprint need modern CNC vertical mills, 3-axis minimum, and high-precision lathes. They need to run industry-standard CAM software and have direct access to high-level inspection gear. We're talking micrometers, digital calipers, surface plates, and ideally, access to a CMM. When a student steps off the training floor and onto an employer's shop floor, the environment should feel completely familiar to them. Let's head into Section 5, Ready for the Shop Floor, inspecting the final product. To guarantee readiness, this entire pathway was modeled after the best, highest fidelity benchmark programs in the country. We analyzed incredible pathways like Workshops for Warriors, which aligns perfectly with NIMS standards and rigorous employer needs. We also drew from Haas Technical Education Centers, Mastercam University, and top-tier NIMS-aligned community colleges. By pulling the best elements from these proven institutions, we get a curriculum that is truly battle-tested and proven to generate top-tier entry-level talent. So what's the expectation on day one for a graduate entering the workforce? It's crystal clear. First, safely and confidently operate CNC equipment without hesitation. Next, accurately read and interpret complex engineering drawings. From there, rigorously inspect components using precision measurement tools. Perform basic setups and make offset adjustments as tools wear down. And ultimately, successfully produce aerospace components that fall exactly within specified tolerances time and time again. Finally, Section 6. We need your feedback. Validating the blueprint. This final employer expectation really says it all. Follow documented work instructions, quality procedures, and show a quality-first mindset. That is the ultimate outcome here. An instructor can teach someone to adjust for tool wear or how to measure a bore, sure. But the real victory of this training pathway is developing a professional who treats every single operation with the immense respect, focus, and precision that the aerospace industry demands. So here is where you come in. We need to calibrate this blueprint with you, the actual industry experts. Think about your current entry-level hiring challenges. Think about the skills gaps you see every single day, and compare them against the 16 to 24-week framework. Does this hit your exact tolerances, or do we need to make an offset adjustment to survive the reality of your shop floor? Let us know. Is this the exact formula we need to build the future of aerospace manufacturing?